Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. It's great to be back, and I'm really excited about today's topic, language agents trained on challenging scientific tasks. I think this is where the rubber really meets the road in AI.
Absolutely, and I'm glad we're diving into this today. It's kind of amazing to think where AI was even 5 years ago, and how far these language agents have come. I mean, the idea that they can actually help us solve complex scientific problems, it feels like the stuff of sci-fi, you know?
Yeah, sci-fi for sure. But also, I think we need to be a bit cautious with the hype. Solving is a strong word, right? I'm not entirely convinced that deep learning alone is the answer, but I'm eager to see what everyone's thinking about this specific paper.
Okay, well, let's jump right in then. The paper we're talking about today is titled Aviary, Training Language Agents on Challenging Scientific Tasks, and it's a really interesting approach to building these kinds of intelligent systems. What struck me is how it blends language processing with actual scientific problem solving, creating this sort of feedback loop. It's almost like how a researcher works, iterating on hypotheses based on evidence and results.
Right, that iterative process is key. I mean, look at how they frame the language agent tasks as what they call language decision processes, or LDPs. It's not just about regurgitating information or generating text, it's about actually making decisions based on the environment, which in this case are very complex scientific ones. That, to me, is a real step up. It's not just a chatbot anymore. It's a system that interacts with a complex reality.
I agree that the LDP framing is interesting. It reminds me of the whole idea of reinforcement learning, where the agent learns by interacting with an environment. But the environment here, being scientific datasets, experiments, and simulations, that's a huge leap in complexity. I wonder, though, how much of the actual reasoning is just clever pattern matching rather than true understanding.
Well, that's the million-dollar question, isn't it? I think the strength of their approach is that it really pushes these systems beyond simple pattern matching. They're not just looking for correlations. They are manipulating things, analyzing the outcomes of these manipulations, and then adapting their approach. In one of the examples they give, it's about manipulating DNA constructs for molecular cloning. It's not just reading a textbook on cloning. It's actually using tools to perform the cloning in silico.
Exactly. It's not just about knowledge recall, it's about active engagement with the scientific process. And they implemented 5 environments: molecular cloning, answering research questions by accessing scientific literature, engineering protein stability, and then a couple of more standard ones like GSM 8K and HOTPOT QA, which they use as a sort of baseline. That's quite a diverse set, and really demonstrates that they were looking at these LDPs across different domains. They weren't just hyper-focused on a single task.
Okay, but let's unpack that a bit. The protein stability one, for example, that's a notoriously hard problem. We are talking about modeling interactions at the atomic level. It's not as simple as searching for text or moving pieces of code. What kind of tools does the language agent use to engineer protein stability? And how much is actual, real biophysical understanding, as opposed to just following a recipe?
That's a great point, and it's actually one of the things I found most fascinating. They're not modeling the biophysics from first principles within the language agent. Instead, they're integrating existing biophysical simulation tools like Rosetta. The language agent uses its natural language interface to query these tools to analyze the output, and then use that to adjust its approach. It's more like a scientist using a variety of lab equipment, right? The language model isn't a replacement for the science itself, but it is directing the experiments based on its understanding of the goals.
Yes, it's like a scientific orchestrator. Think of it as a super-powered research assistant. It can comb through the literature faster than any human and can run thousands of simulations in parallel. And then, based on the results, it can adjust the experiments to get closer to the desired outcome. That's where the language part is so critical. It's how it interacts with its environment, formulates experiments, and synthesizes the findings.
I see what you mean, and I agree that the integration of tools is clever. But doesn't that still rely on the quality of those underlying tools? If Rosetta's output isn't perfect, wouldn't the language agent just be learning biases and approximations? I mean, I understand it's not supposed to be building its own models of protein folding, but it's still heavily reliant on these existing systems. Also, I wonder to what degree is really understanding versus just following the instructions of a very, very long prompt.
Of course, you're absolutely right. The quality of the underlying tools matters a lot. And the language agent is definitely inheriting any biases that are already there. But I think that's also part of the point, isn't it? This shows us that we need both good AI and good, robust scientific tools. It's not an either or. And if the agent is just following directions from a very long prompt, that would indicate poor performance, right? it wouldn't be able to get the good results we are seeing. It needs to adapt to each problem and environment.
Yeah, and it actually goes back to how they structured the language decision process. The goal isn't just to get the right answer, it's about learning how to navigate the process of getting to that answer. They are also experimenting with different approaches. They even used what they call expert iteration to improve the agent's performance. It's not just given a single dataset, it actually learns by generating its approach.
Okay, now that's interesting. So they're not just using supervised learning, they're also using some form of reinforcement learning. I mean, expert iteration sounds like a form of self-play, where the agent is basically playing against itself and improving over time. It is definitely more like a human, not just a black box that spits out numbers.
Yes, exactly. They start with behavior cloning, which is like learning from expert demonstrations. Then they switch to expert iteration, which refines that through a form of self-training. The language agent explores various possible actions. And then it filters out the trajectories that lead to poor outcomes and keeps the trajectories that lead to success. It's constantly updating its strategy. It also shows that these agents are not static. They have a development curve, just like humans.
And this is really where it starts to feel less like a program and more like an actual intelligent agent. It's learning by doing and by getting feedback from its environment. I think that's why their results are so impressive. For instance, they show that these agents, even based on relatively smaller models like Llama 3.18b Instruct, can match or even exceed the performance of much larger closed-source models like Claude 3.5 Sonnet. They are using much more targeted training.
That's a very important point. We hear so much about needing massive models, but this suggests that it's perhaps more about how you train them, not just the size of the model itself. That's exciting, especially for making these technologies more accessible. But on the other hand, I also wonder if a reliance on these iterative techniques could also lock these agents into very specific, perhaps even suboptimal, strategies. What if a better solution is outside of its training experience, so to speak?
That's a valid concern. There's always a trade-off between exploration and exploitation. If you are too focused on exploiting the best solution that you already know, you might miss out on other, potentially much better options. But I think that's where the language part again is critical. It has the ability to reframe problems, to look at them from different angles. This could lead to more creative solutions, not just the most obvious or previously explored ones. I think it is a combination of the known and the novel.
Yeah, and that ability to reframe problems is exactly what makes language such a powerful tool for intelligence, both in humans and machines. It allows us to go beyond simple pattern matching and build new mental models of the world. And that's where the stochastic computation graphs that they introduce in the paper become important too. They allow you to model more complex agent architectures, combining both deterministic and stochastic operations, which are key to both exploration and adaptation. It helps define how the agents think.
Okay, I'm following you, but I'm still not entirely sold on the understanding part. The stochastic aspect you mentioned, that's where it gets really fuzzy, at least for me. These computation graphs, how much of the output is really reasoned versus just random draws from a probability distribution?
Well, that stochasticity isn't just random noise. It's how these systems model uncertainty and explore different possibilities. Think of it like this. If a scientist had a deterministic process for conducting an experiment, they would never discover anything new. They would always do the same thing and get the same result. By introducing some uncertainty, you are opening the system up to the possibility of surprising outcomes. And in these language agents, the language itself is the means to make sense of these outcomes. So the stochasticity is more about exploring a variety of possibilities, not about just a simple random process. And it is always grounded in the context of the specific task.
Exactly. It's not randomness for the sake of randomness. It's a form of exploration. It's like when you're brainstorming, you don't just start with the best idea. You generate a bunch of ideas, some good, some bad, and then you filter out the ones that make the most sense. The language model is doing something similar, using its probability distributions to explore the space of possible actions, and then converging on the most optimal solution. And the key is that it's doing this through language, which is the bridge between the real world and its models. And that's what makes it so powerful.
Okay, that's a useful way to think about it. It's not just simple probabilistic inference, but I still have some lingering doubts about the real-world applicability of this. These environments, even the scientific ones, are still somewhat simplified versions of reality. How do we know that these agents can truly generalize to new problems or new situations that they haven't encountered before? The real world is so messy and unpredictable.
And that's a valid and important question. You're right, the world is messy, and these environments are simplifications. But I think that's true for any scientific study, right? You start with a simplified model, and then you gradually increase the complexity as you understand more. I see Aviary as the beginnings of that. We are creating more complex environments, and now training agents that can navigate them. And I think the focus on scientific tasks helps to move in that direction, because science is all about dealing with complexity and uncertainty.
Yeah, and I think that's precisely the point. These agents aren't meant to replace human scientists, they're meant to augment them. They can handle the mundane, repetitive tasks, accelerate the research process, and explore new possibilities that humans might overlook. I also think that it's important to remember that this is an evolving technology, right? We are going to keep developing better models, better environments, better tools for creating increasingly capable scientific agents. It's not a matter of if, but when.
I see your point, and I'm willing to concede that this is a promising direction. But I still think we need to be careful not to overhype these technologies. It's not about replacing human expertise. It's about finding ways to best leverage the strengths of both humans and machines. So, while I still think there's a lot we don't understand about the reasoning of these systems, I have to admit that the progress is undeniable.
Absolutely. It's all about collaboration and synergy, not replacement. And I agree that we need to be mindful of hype. This field is still in its infancy, and there's still a lot that we need to learn and figure out. But I do think that research like this, which pushes these agents to solve real-world problems, is absolutely essential to progress, not just in AI, but in science itself. It's about building a new kind of intelligent systems that can work alongside us, tackling the biggest challenges we face.
Yes, and I think it's also important to look at the broader implications of this technology. These language agents, especially the ones that can be trained on smaller models, could be really powerful tools for democratizing access to scientific research. Think of the possibilities if researchers in developing countries with limited access to traditional scientific resources could use these kinds of tools to conduct their own research. That, to me, is really what makes it exciting.
That's an excellent point. The potential for democratizing access to scientific tools and knowledge is massive. And one area I haven't really talked about enough is the optimization of the LMs. They talk about how these methods can be used to optimize prompts, tool usage, LM weights, and parameters, all of which are critical for getting good results. So, it is not just about training a model, but also about fine-tuning all these other things which affect how they operate.
Right. And what I found very interesting is that they can even optimize for compute cost, not just accuracy. This is critical in the real world, where resource constraints are often a big issue. They show how these trained Llama 3.18b agents can reach the same performance as larger models for 10 times lower inference costs. That has massive implications for making AI tools more widely applicable. And that really is quite exciting.
Yeah, and that's the point. We're not just talking about some theoretical possibility. We're talking about a technology that is actively being developed and improved upon. And the fact that it can be implemented with smaller, open source models makes it a game changer for accessibility and affordability. It suggests that in the future, any researcher with a laptop will be able to harness this power. That's a shift from relying on large, proprietary systems to something much more accessible and transparent.
Okay, I'm definitely warming up to this. The compute cost optimization is something I had not considered, and I can see the real value in that, especially in the real world. So it is clear that this isn't just some flashy academic project. This really does have the potential to impact how we do science, and that makes it something I am actually very interested in.
And I think that's a perfect way to end this discussion. It's not about creating a replacement for human intellect, but augmenting it, and ultimately transforming how we approach complex scientific problems. This is the beginning of what is sure to be a long and fascinating journey, and the fact that it's open and democratized makes it all the more exciting. Thanks for this conversation. It's been great.
Agreed. It's a great example of how AI and science can feed into each other and push both fields forward. And it's fantastic to see that research is focusing on both capability and accessibility. I'm definitely excited to see where this goes. Thanks for the discussion, everyone.
Yeah, it's been insightful. I have to say that I'm more optimistic about the future than I was when we started. I still have some of my doubts, but this research is clearly moving the field in a very interesting direction, and it's exciting to see where we go from here. Thanks for the discussion today.